This video is for class 9 physics, and in this video we are discussing about the fourth practical, right, which is experiment number 7. The objective of this experiment is to verify the law of reflection, that is, the angle of reflection is equal to the angle of incidence using a plane mirror. Thus our apparatus will be a piece of plane mirror with a stand such that it can be supported vertically, a drawing board, a sheet of paper, white paper, 4 pins, protractor, a pencil and board pins. Now the theory for this particular experiment is the phenomena of reflection of light. So when a ray of light is incident on a plane mirror obliquely, it gets reflected back into the same medium, obeying the laws of reflection, according to which the angle of reflection should be equal to the angle of incidence. Now we can go to the observation table. Now coming to the observation table, here we have written the least count of protractor is 1 degree. We will come to know how. And the table consists of 3 columns. The first column is number of observations, there are 3 of them, and 3 angles of incidence which is written in the second column are 30 degree, 50 degree and 70 degree, for which we need to do the experiment. And the third column which we need to fill after the experiment, which is the angle of reflection, and they should be equal according to the laws of reflection of light. Okay, so let us go to the experiment part. So here are our apparatus. The paper is already placed on the board. Here are 4 needles. This is a protractor, a ruler, a pencil and a plane mirror with the stand. So now discussing about the least count of the protractor. If you can see this protractor here, I am just zooming it, right. So what is the minimum degree which it can measure? It is 1 degree, right. It is this 1 degree. Or if I want to go to the if I want to go to that 0 portion, okay, it will be easier for you to understand. Here the 0 portion here. So now the minimum degree which this particular protractor which I am using can measure is this degree, and this is 1, right, because from 0 to 10 there are 10 equal divisions, hence the least count of this particular protractor will be 1 degree. So I hope you have understood the least count and the apparatus used. Now to do this experiment, you can see that paper is already fixed on the whiteboard, right, and I am taking a mirror such that I need to draw a line, okay, on which it can be placed afterwards. So I am drawing a line on which it can be placed afterwards. Now with this line I am supposed to draw a normal that will also represent a normal for the mirror. So I am taking a protractor and marking it at 90 degree, such that I will have a normal to this particular line. So with the help of a ruler I will join this particular point and the lines point in a which should fall in a straight line. So here I have drawn a line segment which will represent our normal, right. Now after drawing the normal, I am supposed to make one incident ray such that the angle of incidence is 30 degree. So with the help of protractor, I am placing the protractor such that the 0 mark of the protractor is falling on the normal, and then I am supposed to measure 30 degree, right. So here is my 30 degree, so I am putting a point, right, and then I am supposed to join this particular point with the point of incidence, right, with the point of incidence. So here I am joining the point of incidence with that point such that I shall get a ray which can represent my incident ray. So here this becomes my incident ray and my angle of incidence is 30 degree, right. So angle of incidence is 30 degree. So I can put an arrow. Okay, so my incident ray is ready. So next thing what will I do is I shall put this needles, okay, anywhere on the incident ray. So anywhere on the incident ray, right. So I am putting these 2 needles anywhere on the incident ray. Okay, fine. I hope you have understood here. Now placing the mirror back. So I'll get this position, placing the mirror back. Okay, so So when I am looking from the other angle of the camera, right, initially the camera was placed at the top. Now the camera is facing the mirror. Since the camera is facing the mirror, now as you can see here, right, these are the images formed by these needles, right. So I will rotate my position by closing one of my eyes such a way that this particular needle will overlap this needle at the back. Okay, let us try to understand with the help of this particular clip. So here I am rotating myself such that the front needle's image will overlap the back needle, right. So I'm talking about this particular position, right. So let us go to the picture of that, you'll have a better understanding. Here this is the particular scenario I am talking about. Here you can see the needles image, this needles image here, right, is overlapping the back needle, right, back needles image, right. Whenever you are doing the experiment, you need to look at the base here, not at the top, right. You are supposed to look at the base, okay, because the incident ray is lying on the base. So I hope you have understood till here, right. So now the next step will be taking the needles and trying to block these particular images also. Now we are supposed to take the needles, right, the two were left, right. So I need to take the needle and try to put it somewhere around here on the paper such that it will block this particular image also, right. Let us do the experiment. So here what am I doing is I am blocking those images which you had just seen with the help of this particular needles, right. So here I have blocked the images. Okay, let us see from the other view. Here we are getting, from the other view, here we are getting the, you can see I had placed the needles here, as you can as you have seen in the video. So that the images back at here is being blocked by this particular two needles, this and this. So thus I am getting these two needles here and the two images at the back of the mirror, right, on the straight line. Now you can see here these two images are the images of these needles which I have just placed. We are not supposed to do anything with these particular images, right. We don't need them at all for this particular experiment. Thus the two images and the needles which I have placed on the paper, all this are falling on the same straight line. So I hope you have understood till here. Now after that the steps are to take these needles out which was blocking the images and mark this particular dots, right. So I'm marking it so that I can join them afterwards. Okay, so I'm removing the mirror now and I shall take the ruler and try to join these two dots with the point of incidence. So I am doing that, joining these two dots with the point of incidence. Okay, fine. So here, okay, fine, I got my reflected ray, thus I got my reflected ray. So now I need to measure the angle of reflection which should also come 30 degree, So thus here you can see the 0 mark is lying on the normal again and I'm getting 30 degree again, right. So I'm writing the angle of reflection as 30 degree, right, the angle of reflection as 30 degree. So here therefore I can write angle of incidence is equal to the angle of reflection. Okay, so which is 30 degree. Thus my law is verified. So now writing the required what do you say, the alphabets, okay, to complete this particular diagram. So I will represent the incident ray, N the normal, R the reflected ray, and O is the point of incidence, right. So I hope you have understood this particular experiment here. The other part of the experiment also can be proved, which is not there in your syllabus for this particular experiment. Actually, the incident ray, right, the incident ray, the reflected ray and the normal all lie on the plane of the paper at the point of incidence. That is our second law of reflection. Okay, but this is not required for the time being. Similarly, for 50° was also done, right? The same experiment was done for 50° also. So here also we are getting angle of incidence equals to angle of reflection, which is 50°, right? And similarly we had done for 70° also, right, for which also the law of reflection was verified, that is angle of incidence is equal to the angle of reflection, which is 70°. So I hope you have understood. Let us go to the result part. So from the experiments actually we got this the values of angle of reflection here 30, 50 and 70, and thus the result will be the observation table shows that the angle of reflection R is always equal to the angle of incidence I. This verifies the law of reflection. So this much for this video. Thank you so much.